The last thing that we need to go over for this section is an application of trig functions called damped harmonic motion. And this is given by a formula of the form f of t equals g of t sine of omega t plus c, where g of t decreases in magnitude as t increases. So it's damped harmonic motion, meaning each time it goes through a cycle, its amplitude decreases. Well, we don't really call it an amplitude, but you can think of it like an amplitude. So it's like if you ring a tuning fork and then you listen to it, the sound gets quieter and quieter and quieter and quieter, right? Or if you bang a bell or something, the sound gets quieter over time. That's damped harmonic motion. So it's a very common situation. Probably the most commonly used g of t, which you can think of like the coefficient of sine, even though it's variable, is e to the negative t, or e to the some constant k times t, negative constant k. This is exponential decay. So the sound is decaying exponentially. You can think of it that way. It's not necessarily sound, but it's a good way to think of it. So this is exponential decay, and you're kind of thinking of that as the coefficient of sine of 2t, even though it's not a constant. So y equals sine of 2t oscillates between negative 1 and 1. So if you take so for f of t, that's going to oscillate between negative 1 times e to the minus t and 1 times e to the minus t. So it oscillates between the graphs of y equals negative e to the minus t and y equals e to the negative t. The frequency is the coefficient of t over 2 pi, which is 1 over pi. That means put period in quotes, is pi, because it's not actually periodic, because it doesn't repeat the same thing. It's damped. But it's one oscillation. One oscillation it has a length of pi. Each oscillation does. Okay? So here's the graph of y equals e to the minus t, exponential decay. This is the graph of y equals negative e to the minus t. And this is a sine function, sine of 2t. So when you put in 0 for t, you get sine of 0, which is 0. And then 0 times e to the minus t is 0. And so this starts at 0, 0. Okay, so it starts there. It goes up, and it goes through one oscillation, well, half of an oscillation in pi over 2, a full oscillation in pi. So you see what I did? But it oscillates between these two functions, e to the minus t and the two functions y equals e to the minus t and y equals negative e to the minus t. Right? So you can see it has, from here to here is one oscillation. That's this number, pi. So half an oscillation is pi over 2. Right? And then the next oscillation is over another pi. And then it just gets smaller and smaller. And I continued this on the left side a little bit. This is pi over 2, so this is negative pi over 2. But it has to go all the way down here and go up. And you can tell after that it's pretty broad. So usually you're thinking forward in time when you do this. So you're thinking from here forward usually. But I included part of it over on the left. So that's what damped harmonic motion looks like.